Cool, we're recording. This is the Kubernetes SIG Network meeting for Thursday, January 25th, 2018. And let's jump right into the agenda. Got a couple things on. Why don't we start with a quick spin through the test state, and I will share my screen. Yeah, so I missed last meeting. I don't know if you guys had a chance to go through this or talk about it at all. I'm just kind of catching up on it now.
We did go through at least a couple of the test cases in there.
Okay.
Yeah, we did a quick pass through and then looked at a few. Some of them seem to be not SIG Network actually, and then yeah, I don't know if we came to any huge conclusions, but
yeah, looking at it now, things that jump out on me is that we've got like almost every test is listed as flaky or failing, with just a couple listed as passing. And then there seems to be something wrong with all of the kubeadm based tests.
Yeah, on the kubeadm ones, unfortunately, all of those are based on a project called Kubernetes Anywhere, which started out as just someone wanted this type of thing, but it became kind of the de facto for cross-cloud testing. And I've been trying to add some fixes, but there's not a lot of owners in there. And the one owner that I did know now works on Istio. So I can't test things out very easily and have like a high degree of certainty that they worked without more attention on some of the open PRs on that repo.
So, I mean, is that just a sign that we're using the wrong set of tools for running these tests, or
yeah, I mean, it was always like an instance of Kubernetes Anywhere, like a SHA was brought over into test infra, and it didn't have tests running against it itself. And the PR that added that got closed, so now I'm kind of stuck in the same process. It got closed because the kube deploy or cluster API was supposed to be the way forward. So I'm not sure if these should be deleted or like in favor of cluster API evolving, or what should happen. It's probably something we should reach out to cluster lifecycle about, I guess.
Yeah. Do you happen to know anybody who might be knowledgeable on what the planned future for that stuff is?
Lucas is probably the person to reach out to. Either Lucas.
Yeah.
I think there's two Lucases in SIG cluster lifecycle, and I think either one of them that we reach would probably know what to do.
Yeah. So does anybody want to take reaching out to somebody from cluster lifecycle? Figure out what the future is there.
Yeah, I'll own that.
Missing a word. Okay.
So what should we do if some of these don't appear to be our fault? For example, I was looking at that failing one right there, the ingress GC upgrade E2E, and the most recent run looks like it's actually failing on infrastructure issues. It can't SSH into the master node.
Yeah, so I'm aware of that. On our end, we've been working on migrating all ingress jobs to pull from a dedicated project pool with a lot of quota. And that kind of migration spawns a couple of unforeseen issues, but we're aware of them and we know how to fix them. It's just a matter of fixing it. So those should be completely fixed, hopefully, at the end of today.
Okay, cool.
And we think that's both of these ingress jobs are hitting that issue?
Yeah, it's all ingress jobs. So any ingress job you see that's flaky is most likely due to the issues we know about. So
Cool. That's good to hear. So I mean, I guess that kind of sounds like most of this is infrastructure stuff that we have to get past first. These failing and flaky, and then all the KubeADM ones as well.
Are the upgrade downgrade ones passing now? Towards like the end of the list.
Oh, the kube proxy stuff. Those are also listed as flaky. Looks like we've had some.
Hello, this is Zihong from
Mhm.
Google. I take a look at the test. I think the failure is because we are leaking some resource after upgrade and downgrade, and it's not failing; it's just flaky. I will take a look.
Leaking like an infrastructure resource, or
Like ingress resource or something. This ingress like doing the upgrade and making sure it's working, things like that.
okay. So you're comfortable looking into what's going on there?
Yeah, I will look at it.
So quick question, Casey, what exactly does flaky mean here?
Oops.
Is it like,
That's a good question. I'm assuming it's some percentage of tests failing over the past amount of time. I don't know the exact definition.
Yeah, I mean, the concern I have is that there might be a lot of noise in some of these results, because if it's flaky, we don't know whether it's flaky because of our problem or because of somebody else's. And then even if it is somebody else's problem, then it'll still be showing as flaky for at least a while, probably at least a day.
Yeah.
So it's kind of like, it's a little hard from these results here to tease out what we really do need to pay attention to consistently. I mean, obviously you can go through the list once at one time and be like, okay, this test, not our problem. This flake, not our problem. This flake, not our problem. But then how do we kind of know that the next time we go through in like a couple of days later that, yeah, I don't know. It just seems like there's kind of some noise in the results, and it'd be somehow nicer if we could actually pin the failures on SIG Network stuff, but I'm not sure how that could happen.
Dan,
There
would you
was
be
a
happier?
way to filter.
Question here. Dan, would you be happier if in the summary, in addition to showing the failures in the past week, it also showed the failures in the past day?
Yeah, that might be nice. Or just, if I knew what the criteria was for flaky.
Well, look, it has to be up to us or somebody
Yeah.
to figure out, what the cause is. We can't ask the tooling to figure out the cause, but we can ask the tooling to give us more visibility into things fixed recently.
Yeah, well, I mean, okay, so one example, which one was I looking at? I was just looking at one of these, the GCI GCE one, which is listed as, I think that's one I was looking, yeah, that one's listed as flaky. But it flaked in one test.
Yeah, that was a long time ago.
Yeah, but then also, what I was looking at was if you hit the about, and then you go see these results in Kubernetes, it looks like there's a lot more failures there. Yeah, so if you see that first failure,
yep,
right there, that one is actually a SIG storage failure. So is the tooling good enough to ignore that particular one? Because, I mean, I don't Maybe this is just me not quite understanding the presentation of the tool here. It's like, given that, so if we go back to the, yeah, you're in the right spot. Go back there and you'll notice that the DNS should provide DNS for pods. That's the one that failed most recently, and it failed looks like this morning. How do we actually get to the test results for that specific test? Oh, hey, never mind. I guess you can click on it, but you don't actually see that you can do that. Okay, so never mind. It's just my confusion and my unfamiliarity with the tool.
Yeah, I think we're all sort of figuring out how all this stuff hooks together.
Yeah, so it's not obvious, but you can actually click on the red square.
Yeah.
And that'll pull up the exact, which is what I was looking for.
Yeah, I mean, it looks like it's smart enough to filter out this SIG storage stuff because
good.
That's not showing up in this dashboard. It's only showing the individual tests labeled as SIG network.
Yay, smart tools. Who'd have thought?
Is the whole thing still, though, like showing as flaky, like how we have it marked?
Yeah, that's a good point. Where did I put that?
Because if so, I think that's a change that I made. So I noted the same things that Dan was, like it'll be a SIG storage test that failed. So for a given job, if that happens, the whole thing is marked as flaky. So I used some of the regex that I saw before to filter to just SIG network stuff, but that appears to not potentially have effect on the whole suite if you're just filtering, because it just shows what's displayed, I guess, if that makes sense.
I think I'm following. Yeah, I mean, this is a summary of.
I'm afraid I'm not. I mean, if we go back to that one that Dan Williams asked about a minute ago, and you click on it.
Yes.
Oh, never mind. I see it. Yeah, there's one. Never mind.
Yeah, so I think what it's doing is you've got this GCI, GCE suite of tests of which only this subset are SIG network, but the overall thing can show up flaky because there's some SIG storage failures in there as well.
So with that one, looking at the summary that's there, it says 17 of 10,332 tests failed. And yeah, that seems to be about right. But then 98 of 287 runs failed in the past week. Do we know what the runs part is there? Like, does that even matter for us or matter for the SIG?
See, that's what if I understand that correctly, which I very well could not, those numbers are not super important for us because I think the run is the entire like GCI, GCE test.
Okay. But then the 17 of 10,000 is the SIG network related tests.
I would assume so.
Yeah, I mean, I think
that to be meaningful, that 10,332 has to be instances of the GCI GCE test.
Yeah, I think that part is correct because we've got, I don't know, 25, 30 odd tests. And then if you go back a whole week, there are a crap load of, cells in that display. And I did a quick count and there are about 17 that actually failed in that entire display in the grid. But what I'm wondering about is the 98 of 287 runs. And maybe that's kind of pointless for this call, and I should just go figure that out somewhere else. But
well, maybe it shouldn't be everybody privately figuring out. How about somebody just tell us?
True.
Let's delegate someone to figure that out and tell us. I'd like to know.
I mean, the end result is how do we separate the noise out of here and actually figure out what we need to pay attention to? So, yeah, I don't know. I mean, maybe we just... The other thing is, it would be nice if there was kind of more of a dashboard here.
What would be more of a dashboard than the summary?
Something that I don't know. Well, whatever. I'll follow up maybe with the people working on the tool and give some impressions about that.
Yeah, I can try to go out and find some SIG test person to
Okay.
tell me how this all works. So I'll do this one.
I mean, I've sort of been looking at this tool for like the past couple of weeks, and every time I go into it, I take a look at a test case, but then, I come back and I'm like, wow, this isn't really helping me get my job done.
Yeah, and I'm sure the test guys are anxious to get feedback on this anyway.
True. Yeah.
So, let's just.
Also, do we have any idea of which tests are more important to concentrate on? I mean, like, is there a set of tests that we should be looking at every single day or every other day to make sure that we actually work to get them fixed? And then some others that we don't care quite as much about because, clearly we have limited manpower or person power as it is.
Yeah, I mean, I think that's definitely the case. But I don't know that we know which ones are which.
And maybe that's some feedback that we could send to the tool people is if there's a way to kind of sort the tests by importance of what the SIG thinks is important.
Yeah.
So that they show up on top as opposed to having to scroll through the list to find those. And then, at least then you can kind of take a look at the top 5 tests or something and be like, hey, our most important tests are failing. And that's a lot easier to see more quickly.
Yeah, this is all good stuff.
Okay. Well, anyway, maybe to cut myself off, do we know which ones are most important that we should focus on right now and dole out to people to kind of triage? I mean, we know the ingress ones are probably broken.
I'm looking for help from the audience on that question.
Yeah. Let's see.
Which ones have we not identified an owner for?
Is that what we should do? Identify an owner for specific tests?
Maybe just to deflake them for now and then bring it back to the group.
True.
I could take all the Kubernetes ones. I think someone else mentioned that they can take ingress and kube proxy upgrade downgrade.
Yeah, it might be good to have written down somewhere like who owns and who knows each set of tests best. Because I'm sure that each of these has somebody who understands them really well, but it's hard to find that person. So Christopher, you said you were going to do Kubernetes ones for now.
Yeah, I mean, I could take on more if no one else volunteers, but I can't promise that I'll be able to
I can take
troubleshoot them.
Sorry, I can take the Q proxy one. Let me type.
Okay. Yeah, if anybody wants to own a test, feel free to put your name down in the notes there. Cool. So I think that means we've got a couple owners for tests, and Dan and I will try to reach out to the SIG testing guys, give some feedback, and get a better understanding of what this summary is actually showing us.
So maybe next time we can do a short presentation for the group.
Yeah. Yeah, that sounds good. In that case, unless there are other questions on that, why don't we move on to the next topic?
Is that me?
That's you.
All right, so there's a listed issue there, and one of the things that we had been looking into was running pod data plane on a separate network interface. Now, this doesn't have anything to do with multiple networks in Kubernetes really at the moment, but it's more about having the masters and nodes be able to contact each other on one network or one IP network, and having the pod data plane run on a different one. And it turns out that there are it's not particularly easy to do that. And there are a lot of dependencies in the code where, for example, if you're, I think it's if the node IP, or the host, I think it's the node IP, yeah. So when you start a pod, the pod gets a pod IP, but the pod also has a node IP. And some things in Kubernetes use that node IP where they probably need some other kind of address if the pod's data plane is on a different network. So I'm probably not describing as well. The issue actually talks much more detail about it. But I was wondering if anybody else has sort of tried to do this kind of thing with Kubernetes, and then if people have come to any conclusions with that, or if they've tried it, what their approach was, and then there's kind of an approach outlined in this issue that might be useful to try out. And
So
the solution proposed there was a new, a new node address type. Let's see, I'm trying to remember exactly what that one was. We were proposing one for the control plane, I believe, because there's enough stuff that uses the node's current address for data plane type things like kube proxy, for example. And so by specifying a new address for control plane, e.g. Nodes talking to the master or master talking to nodes, that was kind of a way to not have to modify a ton of Kubernetes. Does anybody have questions or need clarification on anything? I mean, it's just kind of a request for, if anybody has tried this, let me know. We can talk about it here if this is interesting to people. Otherwise, we can just keep it on the issue.
yeah, it's interesting to me. I'm just trying to parse everything you said because I haven't read the issue in detail.
So I mean,
it's
think of it this way, for example, oh, go ahead, Mike.
Yeah, I was going to say, at IBM, we always use nodes, usually use nodes with two interfaces, and we care about what goes over what. I'm trying to remember what I've done about this, and I don't really remember the specifics. I don't quite understand why it's a Kubernetes issue at all. I mean, the node address is used for, platform communications, and the pod addresses are used for data, and it's up to the routing rules, which are not something Kubernetes manages anyway, to tell what traffic goes over what interface.
Yeah, the issue is I'm trying to remember exactly what it is. So okay, one of the problems is pod.status.host IP. What kubelet does is it'll grab the node IP from node.status.addresses. And so your node IP is going to be, usually that's going to be, I think, whatever the host's IP address is, or whatever you've set the node IP for the node as. But the node IP is also used, I think, when the master wants to directly talk to the node. And there's a couple of cases when that happens, because there's two ways that nodes and masters can communicate. Sure. The node can actually ping the master and keep the connection open. And by this, I mean API serve, essentially, and register itself. But there's also cases where The master talks back to the node. I think some of those are for like cAdvisor or status or other things like that. So, but anyway, the point here being that node IP in the pod status, or that host IP in the pod status, gets used in some places like kubeproxy, for example, and that might not be correct in kubeproxy.
Yeah, kubeproxy, that would be a mistake.
Because
So
I mean, if
that
the,
that
sorry,
list
go
is
ahead.
already like a slice of addresses, right? So is
Yep.
it just picking the first one, or does it have some logic already to determine what?
I think it uses like, there's a couple of address types. One is internal address and external address. External address is supposed to be if that node has like an internet public address or something like that. Internal is supposed to be the IP address of the node, like within, you know, your private network. So, but neither of these are exactly right, because, you know, you can think of both in the split kind of control and data plane case. Both these addresses could be private. Neither one of them needs to be publicly accessible, like node external address. But yet you want certain traffic going over one or the other.
So let me try again.
Sure.
The node addresses should only be used for control plane.
Yeah, unfortunately, they're not.
Yeah, okay, so that's the issue. What uses node addresses for data plane?
Kubeproxy, for example, pulls the node address out of host IP from the pod status, I believe. Or that gets somehow propagated into endpoints for the endpoint controller. I should probably go off and figure out exactly what's going on there. But that's one case.
It definitely sounds wrong. I mean, clearly, if you've got a pod that's using host networking, of course, then you don't want a distinction between control plane and data plane. I would call a distinction between platform and workload.
Sure. I mean, I'm just thinking like, you know, any traffic that is to or from a pod versus traffic between a Kubernetes node and a Kubernetes master.
Well, unfortunately, you have to talk about to and from at the same time, right? So you've got a clear answer when it's from a pod to a pod. You've got a clear answer when it's from a worker or master to a worker or master. The other two cases is debatable because it's crossing this boundary.
Yeah, and I mean, host networked pods are still pods.
Okay, so
Right.
what I meant is I should correct what I said, right? Where I said pod, replace it with pod that's not using hosted networking.
Gotcha.
Okay. Yeah, I mean, the issue happens here when, well, anyway, I think that's what this has made clear to me, is that we need to be more specific in where this boundary is kind of crossed or violated in the issue. So
yeah, let's start there.
I'll go do that and then update that issue. And then if anybody else on the call is interested in this, that issue is there and we can kind of continue to discuss.
Yeah, I'll definitely read through that. Cool. Thanks, Dan.
Thank you.
Minhan, I think you're up next with pod readiness, plus.
Yes, this is Minhan speaking. So I wrote this down, and this has been a problem since like the birth of Kubernetes. So basically, pod readiness is defined as all its containers are ready, and whether its containers are ready or not is based on the feedback from the runtime and the readiness probe. So the pod readiness essentially is solely determined on kubelet. And on the other hand, like services, they use service selectors. That means the services has like implicit backends, and that basically further encourage the workload APIs to basically ignore services in their decision making. And the workloads generally, like deployment or daemon set, they generally only look at the pod status they're managing.
So this creates a gap between the service lifecycle and the pod lifecycle. Like, let's say you have a pod starting up. You want it to be ready, and not only in the sense that its container is ready to serve traffic, but also like it's supporting infrastructure, like network policy rules are in place across the cluster, or like IP tables are already fully already propagate the programming of IP tables across the cluster, so that eventually you claim this pod to be ready.
Right, and it also has the same problem going down, right? For all the load balancers that point to a pod, you want to know when they stop pointing to a pod as you take it down.
Yes. Basically, that's the problem. The two sides of the problem statement. One is the on startup. One is on teardown.
Right, and it matters for all the load balancers that point to pods, including, for example, the cluster load balancer.
Yes. So that's why, because this is sort of a big API change in Kubernetes, if we want to fix this properly to make the workloads more like service and network aware, so we have to introduce an extra state somewhere. Either we delegate the workloads decision making to some external stuff, or we need to allow like external feedback into the pod status. Right. That basically there's no way around it. There's only two way forward. So both of these options are sort of a big change to Kubernetes API. So, and since this is mostly impacting the networking folks, so I first wanted to basically send out this problem statement and the survey and see like whether folks are feeling the pain of this problem, and then how much support, how much determination we want, we can get from the community to say to push this API change forward.
Can you say more? I haven't spent much time thinking about the solution. What are the two ways you're thinking of to solve it?
So generally, there's only two ways, right? One is you have some extension point on the workload side to say, okay, you consider more instead of only the pod readiness, right? Which is currently solely depend on kubelet, right? You either
by workload side, do you mean the consuming or client side?
No, like the deployment controller have a extension saying that, oh, like when you do this decision making, you have to talk to somebody else and get more feedback about the pod, or the pod status itself needs to allow external feedback. Okay. Right now, the feedback loop stays within Kubernetes, which means basically kubelet updates it. Only kubelet updates it. Sounds reasonable, right? So basically that's the two directions we can, but both of those the directions are quite disruptive to the core Kubernetes API. So yeah, we wanted to send out a survey and see how much support we can get from the community.
So one of the things that I find troubling as I start to think through this, as I said, it seems to me what matters is everything that points to pods. It needs to track pods coming up and coming down, including all sorts of load balancers. And I remember Kelsey Hightower a couple of KubeCons ago emphasizing how services are training wheels, and you don't have to use them, and you can use whatever you want to load balance. So that's really an open set of things that needs to be tracking pods coming up and going down. And whenever you have an open set, there's got to be some responsibility on the members. These things that are tracking pods, they've got to be updated to let Kubernetes know that they've tracked it. So whenever you're talking about making a change in an open ecosystem, you can't expect it gets done in any particular amount of time. So now we're going to have a situation where some of the things that need to track it are actually using our new API for tracking it, and some of the things are not.
Yes, yes. So that basically brings down to the proposed like solutions. Either we wanted a very disruptive like proposal that like basically enforce everybody to consider the cases, or we say a more of an open-ended like solution where you can say, okay, if you care, then you consider it. If you don't care, then you just stay whatever you're doing.
Well, there's two sides of caring, right? One is, in some sense, the consumers of the pod's service. They want to know when the pod really is ready and when it really is not. And the other is the intermediate providers of load balancing. They're the ones that are in this, the unbounded things that we're never going to find them all, and that need to all get updated. Well, but we can't require them to all get updated because they never will.
But then that depends on what's your definition of like ready plus plus, right? It depends on how you define it.
It seems to me the core of your problem is that there are consumers that go indirect through load balancers, and load balancers take some time, and policy enforcers and various intermediaries, right? There are consumers that go through intermediaries, and so the pod isn't really ready when it's coming up, right? Or it starts to go out of service as it goes down, as his intermediaries change their handling of the traffic.
That can be one case. That can be one case. Yes.
What are the other cases?
Like for instance, like pods come and go, and then you have network policy in place or not in place, and then you have like security gaps or like the IP tables that are not in place, and then you don't know how to debug it and what happened because
right. I thought I was including that. By intermediaries, I include the processing that the kernel does due to IP tables.
Yep. Yes. So basically, in order to properly solve this, right, we need some kind of extension point somewhere, right? So I first I wanted to like ask the last folks if you see this as a very severe problem, or is it like a livable problem that okay it can be solved or not solved, or is it like must be solved in Kubernetes, or it should be solved in some higher like constructs or some kind of service mesh that built on top of Kubernetes?
Well, even with a service mesh, you get a higher level concept. It's going to have a higher level intermediary and have the same problem again.
Yes. But if your customer, your users are interacting through the higher level API, which already handles this kind of shortcomings of Kubernetes itself, then the users will not observe this problem anymore.
Okay, if you're going through a high-level thing that is self-contained and that it knows about all the intermediaries that matter,
then it's already
in order to answer your question, right? As soon as you say the word security gap, there are some people that are going to freak out and they're going to say, no, I can't use Kubernetes until that problem is solved.
Yeah. Then that comes back to your definition of the ready, right? It comes back to whether you want to say, okay, all the security policies are enforced for this new pod or whatnot, to consider it fully ready or not.
If I may add something, it's also sometimes a problem of when there is a problem, reporting what kind of problem occurred and letting the user know that a pod is not able to come up for a specific reason that the kubelet may not be aware of, like some failure in the networking backend, and it would be very useful to be able to provide status updates. for this reason.
Yeah, that's one use case. Like you can have a event that directly attached to like the pod saying that why it's not ready because it's some underlying dependency is not ready and things like that.
Yeah, it sounds almost like we need something like the concept of node conditions. All right, there's a set of pod conditions that can report whether this pod is ready or not. And so someone who wants to diagnose an issue can look and see why the pod is not ready yet.
I don't think this is related to node condition. Yeah, it's
no, it's not node conditions. It's just like it. I'm saying it's a similar concept.
Yes. Yeah, I mean this item is mainly for gathering feedback and see how much support we can get, and then obviously this will be a very disruptive like API change if we want to fix it. So basically, I want to see like to what extent we wanted to fix it in core Kubernetes API. Like, do we want to fully fix it, or do we want to partially fix it, or we just want to like provide extension points and whoever want to fix it just use it, or things like that. Yeah, and then how flexible people want this to be. Would it want to be like a blocker, like blocking from the initial transition from ready to ready plus plus, or you want to block, like you wanted to have continuous like a status update which interlocks the pod lifecycle, or things like that. So basically that's what I'm trying to figure out in this survey.
Do we have a set of users who have said that they've been bitten by this? Like what kind of brought this to your attention?
So I have so we have a bunch of users which like run into similar problems, which we can't have a proper root cause. Like let's say there's no logging, no snapshotting of the IP tables state at the time the problem showed up, or it's an intermittent problem or whatnot. So when facing this kind of like the mismatch between pod lifecycle and the network or service lifecycle, this kind of mismatch, the only way we can do is to reproduce, like to try to find out what are the operations the user perform, and then try to snapshot it and then figure out what happened. Yeah. So and then we find out this is sort of like because the behavior is undeterministic. So we got
a bunch of symptoms that could be explained by this, but
it could be explained by this or not, or and
right,
then we feel like we should seal the gap. So first we need to say, okay, whether we think this is a gap, and then to what extent we want to seal the gap, right?
Yeah, I'll also add that I've also seen colleagues in IBM basically saying, I get these occasional, 500 errors, or let's see, was it a little 500? Yeah, it was 500. Or request drops, the problems that could be explained by this. Don't know whether they actually were, but, clearly this kind of thing is going to give interruptions in service. And I have colleagues who are reporting interruptions in service.
Yes, especially for like users, which is very sensitive to like this kind of disruption. Yep. Okay, so I would encourage everybody to go through the problem statement, and then there's just a few like very brief description of the direction of the proposal, and also there's a survey and see how much support we can get from SIG Network, and then present it to the wider community. Okay, thank you.
Awesome, thank you. So I think that was the last thing on our agenda today. So unless there's any last minute topics, I can give everybody 12 minutes back. All right. Next meeting will be in 2 weeks. Thanks, everybody.
Thank you. Thanks.
Thank you very
Bye.
much, everyone.
Thank you.
Bye-bye.